Hello, my name is Derek from Tomcat Gas Training, and the video you're about to undertake is all about safe isolation of one of these. So what we're going to be looking at is the tests we need to carry out as a gas engineer on the electrics before we're removing a cover of a boiler and before we're putting our little pinkies into the PCB. So let's stop messing about, and without further ado, let's just get on with it. Now the first thing we need to do is have a look at the test equipment we're going to be using. So let's go and have a look at that. First thing we're going to be looking at is Technical Bulletin 118. Now Technical Bulletin 118 from GasSafe, this provides us the information as registered gas engineers and businesses, what procedure to follow and what is best practice. So the GasSafe Register is an official gas registration body for the United Kingdom, the Isle of Man and Guernsey, if you didn't know, and it's appointed by the Health and Safety Authority for each area. By law, all gas engineers must be GasSafe registered before we can work on any gas appliance. Technical Bulletin 118 from GasSafe, this is our best practice document we're supposed to be following for the safe isolation of gas appliances. Now the two pieces of test equipment we can see here. So this is a socket tester from one of our favourite DIY stores, and this is a digital multimeter. According to Technical Bulletin 118, these are no good for testing for safe isolation. And these are probably the most common things gas engineers carry with them for testing electrics. But we're not allowed to use these according to 118 because they deem them not suitable. So let's have a look at some suitable test equipment, what we're going to be needing to purchase to be able to comply with Technical Bulletin 118 and the new ACS assessment, which was going to come out in August, hopefully 2020, where we're going to need to prove competence at being able to test safe isolation. So let's have a look at this equipment. Now this is the test equipment they do deem suitable for testing via 118 Technical Bulletin. So let's have a look at these in more detail and see how they work. Now, the first thing we're looking at is what we call a non-contact voltage indicator. So this is basically a single pole or non-contact live circuit detector, sometimes referred to as a voltage stick. It should only be used for identifying if the equipment is live, and you should not use it for proving that any electrical circuit is dead. It's only for testing to see if the boiler casing is live. So this is one of the better ones. It has a torch on it. Torch is bloody useless, but it does tell you that the batteries are okay. And then this is the on button, and we need to prove that this is working, then use it, then prove it's still working. We're going to go through the test for that. So that's the first thing we need to look at. And the other thing what GasSafe say is it should be lower than 50 volts. Okay, this is actually 1 to 1,000 volts, so we can use this. So this first figure we're here, 1, GasSafe say it has to be lower than 50. Okay, so that's the one we're looking for. So this is a reasonably good one. Now, one of the tests we need to do is perform a polarity and earth loop impedance test. Now, for gas engineers, we're not electricians at the end of the day, and we don't want to be spending thousands and thousands of pounds on fancy electrical equipment when we've got this little beauty. Okay, so this actually covers our earth loop and impedance test. It also does our polarity checker, and it can also check RCDs as well. So this is the ideal little tester for testing class 1 appliances. So boilers come under class 1 appliances because their earth is enclosed. This equipment is important that it is basically testing the power supply and making sure that our earth is in the right place, our live is in the right place, and our neutral is in the right place. And also that we've got this earth loop impedance checker. So we're also going to see how we're going to use that as well. We're also going to need one of these, and this is a power supply proving unit. So this proves AC and DC power sources. Okay, and we're going to need this to be able to test our test equipment, to make sure the test equipment is working before and after and during we do the tests. So if we don't know a known supply, I don't know why a known supply isn't good enough now, we need to have one of these little things. So this is our proving unit. Now this is what we're going to be needing to prove that our incoming supply to the boiler is dead. So this is a 2-pole voltage indicator. Okay, it's safe and simple to use. It has to range between 50 and 400 volts AC and DC. It's got to be automatic basically. And this is what we have to use instead of a multimeter. Okay, because they can say the multimeters can give us wrong readings. So we need to use one of these. They're fully automatic. So we're going to be seeing how we test using this too. So that's the basic test equipment we're going to require. So let's go and see how the bloody hell we're going to use them. Let's get on with it. Now you can see this boiler is fed from this power supply. This power supply, you can see, is a switched plug socket. Now, boilers should not be fed via a switched socket. They can be on a plug top, but the plug has to have a 3 amp fuse in there, but the socket should be unswitched, and that is just purely for safety reasons, because we don't know whether this is a single pole or a double pole switch, and also the customer could accidentally turn this on if we left it plugged in. So yes, a boiler can be fed via a plug top, but the plug top must be in an unswitched socket. But we've got this switch socket, so we should be advising the customer to get the socket replaced by an unswitched one, or better still, get a fuse spur installed, because the fuse spur is double poled and it's the best way of isolating a boiler. Okay, so we're going to test this now. So what we've got is our handy little socket tester. So what this is going to do is it's going to test our polarity. It's going to make sure that our live, neutral and earth are in the right place. It's also going to do our loop impedance test. Now it does have an RCD checker on here, but this socket is not protected by an RCD. It's protected by an old fuse box. So we won't be using the RCD checker. So removing the fuse, I've got it turned off. I'm removing the fuse, removing the plug. I'm now going to put in our handy little socket tester, plug it in, and I'm going to turn it on. Now, when I turn it on, we should be getting some 3 green lights there, which will tell us it's correct. And we should also see the loop test will give us whether it's good, whether it's checked, or whether it needs urgent check. So let's see, let's turn it on and see what happens. So we've got 3 green lights, we've got a continuous beep, and it's just done our earth loop impedance test, and it's telling us we've got a good earth. If I press this, we can now see we've got flashing, it's green, it's correct. So get rid of that irritating buzz. So now I know this has got an earth in the right place, a live in the right place, a neutral in the right place, and the earth has been tested and it's correct. That's the first test, and we now know this socket is a known live supply. Now, just to prove we have got this voltage, I've got my little device here, which when you plug it in, it overrides the little gates. So it's got some little holes in here, so I can check using my 2-pole voltage detector, which I've already proved is working, to see whether I've actually got voltage. So what I'm going to do is I'm going to turn on the power. First thing I'm going to do is I'm going to put the black probe into the earth connection all the way in, and I'm going to put my live into the live connection, and I should get 230 volts, which I'm getting 230 volts. Okay, now if I go onto my earth and then go onto my neutral, I should get earth continuity, which I am doing. And if I go the black lead into the neutral and then that into the live, we should get 230 volts, which we do. So that's proving that we've got 230 volts. Now, because I know this now is a live known supply, I can now test my non-contact voltage indicators working, or volt stick. Okay, so the first thing I'm going to do is turn it on. So you can see the power's on now. I need to turn my socket on. Now I know that is the earth, that is the live, and that is the neutral. And the way we have them in the UK is they've got little gates on there to stop you sticking your fingers in. Now you can see the voltage indicator's got this little, for the want of a better word, sticky out bit, which allows us to push it towards the known supply. So you can see this is bleeping and it's got the red light on to show me that that is alive. If I go onto the neutral, it's now showing me a lower beep and a flashing red light to show it's got some kind of supply there, and it's got the earth as well. It's showing me this earth there as well. So I've just proved that this is working with my known supply. I could also use my little power pack to prove that it's working as well if I didn't have a known supply. So I need to prove it before I use it. Now, I know this is working, you've just seen me prove it. So dead simple to do now is, remember this is non-contact. You don't need to start whacking it on the casing because you can see it's giving you a reading. So it's called non-contact for a reason. You just need to sweep around the metal parts of the boiler. Now you can gently touch it if you feel that way, but remember it is a non-contact. So you can just sweep around the casing, making sure that none of the sides, the flue, you can even do the flue, and you also need to do the pipe work down at the bottom and make sure that none of the pipe work is live as well. Okay, so that's it. Now we've proved that this isn't actually live, we can stick our hands in. No, we can't, because we've now got to prove on our known supply that it's still working. So I now know I can touch this boiler in confidence and I'm not going to get electrified. Now, what also we can do with this, even though gas safety, this isn't a proved thing, we can see if we've got an earth at the main earth terminal on the boiler. So if I plug that into the earth and then that onto the earth terminal on the boiler, we should get earth continuity. So let's see if we've got that. So if I plug that into my earth terminal and then this onto the main earth terminal of the boiler, we should get a bleeping and we should get earth continuity, which we are doing. So that means the earth in this boiler is correct and it's working. Okay, we do have an earth. Okay, so that's showing us continuity. And we can even test that we've got the earth between the socket and the pipework. So we can see we've got continuity, earth continuity on all the pipes. Now, we're going to be testing this boiler for safe isolation. I've got the power supply turned off. Now, the test equipment we're going to be using is this double pole T90 voltage tester from Fluke. Now, first thing is we need to check the probes on the end here. Now, what the regulations say is we should only have 4mm sticking out the end, or better still, only have 2mm sticking through the end. But what I've done is I've removed the protecting, the screw in the end here. I've removed them off so you can see it better. So hopefully I don't get electrocuted. I won't get electrocuted. Anyway, the other thing is as well, we need these finger guards. So on the two on the main body there's a finger guard here to stop you going any further than that, and on the black lead there's another finger guard to stop me going any further than I need to. Now the first thing I need to do is I need to check and make sure there's no breaks in my cable. Okay, so that's important. So whenever you're using anything, whenever you first get it or you first take it out of your tool bag, just run your fingers along the length of the cable to see if there's any nicks or breaks or you can see anything. Once you're happy with that, then we need our proving unit. Now this proving unit does AC or DC. I'm going to be working on the AC, so I've set my proving unit to AC. Okay, so it should, when I push my two leads on the positive and negative, it should light up and tell me on the front of here that I've got 230 volts. Okay, so let's have a go at that. So I'm going to put my live onto the live, neutral onto the neutral, and see what we come up with. And I'm getting it flashing at 230 volts. So that has just proved that this little voltage tester is working. Now, first test I'm going to do is I'm going to make sure it's dead. Okay, so the plug is unplugged, so it should be dead. Now the reason why we've got to do this is because we've got separate controls on this boiler, and somebody could have wired the controls in wrong. So we could be getting backfeed through our controls. We could also have, if it's a Y plan or an S plan, somebody could have put another supply in somewhere. So we could be getting backfeeding down a switch live. So I've unplugged it and I'm going to test now and see whether it's dead. Now, first thing I'm going to do is I'm going to put this black lead onto my earth, and then I'm going to put this onto my live, and I should have no voltage. And I've got nothing. Now I'm going to put it between my earth and neutral, and there should still be nothing there, which there isn't. And then I'm now going to put the black lead onto the blue neutral wire, and this onto the live wire, okay, the brown wire, and I've got nothing. Okay, so I can assume this boiler is dead. Okay, now what I'm also going to do is I'm going to put this onto my earth. Okay, and I'm now going to test all the other wires, okay, and see if I've got any voltage coming back through the wires, and there isn't. Okay, but I do know all this side of the board on an Ariston boiler is low voltage anyway, but I've got nothing coming back, so I can assume it's safe, but I've got to prove that this is still working by getting my proving unit and putting my wires back on again. Oops, really hard to do on your legs. And proving that it's still got a supply, which it has done. So I can assume now that this has been isolated completely. Now, the next test I'm going to do is I'm going to do polarity test and make sure that the wires are going to the right place. So from the plug to the boiler, we've got the right live, right neutral, right earth. Okay, now I know the plug itself is right because we've tested it. So what I'm going to do again is I'm going to place that on my earth and this on my live, and I should get 230 volts. So first of all, I'm going to switch it on. Okay, can hear the boiler coming on. I'm just going to make sure the boiler is turned off on the front. Okay, the boiler is turned off on the front. Okay, now I know there's some power going in here because everything's started to work. You've got to remember, guys, this is a live test, so we've got to be very, very careful when we're doing these tests. Okay, now, first thing I'm going to do is I'm going to place the black lead onto my earth cable. Okay, I'm now going to take the voltage. I'm going to make sure my fingers don't go past the finger stops, and I'm going on to the live. And you can hear and see I've got 230 volts. So that's correct. So I know that brown wire is the live wire. Okay, I'm now going to go between my earth and my neutral, and I should have nothing. And I've got continuity. Okay, so that's good. Okay, and now I'm going to test between my neutral and my live, and I should have 230 volts. And I've got 230 volts. Well, it's between 220 and 250 volts. Okay, because it's AC, alternating current. So I know that my polarity is correct for this boiler. Okay, I know when I turn the switch off and I pull the plug out, it's dead completely. So I've done the dead test and I've done the polarity test. Okay, I've done my earth loop impedance from the plug, so I know I've got an earth, and I know I've got an earth because I've just been testing everything. Okay, so that's how you test for safe isolation on this boiler following technical bulletin 118. Now there are other tests we need to do if we've got a fuse spur, so let's have a look and see what we would do if it was fed via a fuse spur. Now there are lots of different fuse spurs what feed boilers, but we're going to have a look at testing them. But if we do have a boiler fed with a fuse spur, then you would have to do your earth loop impedance test at the appliance. We could actually do it in this because this power for this fuse is taken from this socket, so we could still use our socket tester to see if our earth loop impedance is okay from here. Again guys, we're not electricians, we're gas engineers, so we're only here to check to see whether it's safe. But we'd have to do more tests at the appliance if we did have a fuse spur, and we would probably need another tester, which are a lot more expensive if we do have a boiler fed with the fuse spur. Anyway, let's stop messing around and have a look at this fuse spur and see how we isolate this one. Now, if your boiler's fed via a fuse spur, things we need to do are: one, we need to turn off the fuse spur, then remove and retain the fuse, and this time you can check as well and see if it actually is a 3 amp fuse. Then we need to get a little padlock, and this little padlock is going to stop anybody messing around with our installation. And we need to put this little sign on as well at the same time and fasten up the padlock if you can get your big fat fingers in. So that is now padlocked off. That has now got a sign on it, and the sign says, "Caution, do not remove this tag." And the tag on the other side says, "Caution, do not operate electricians at work." So that will stop your customer from turning the boiler on while you're working on it. Now that is the end of this video on safe isolation of a gas boiler. Now remember guys, we're gas engineers, we're not electricians, so don't start going putting sockets in, don't start going putting fuse spurs in. That's not our job, that's an electrician's job. These tests are just to show you how to stay safe. Okay, so if you've enjoyed this video, why don't you give us that thumbs up or leave a constructive comment down below. If you've not subscribed to our channel yet, then please subscribe, and don't forget to hit that notification bell because I release videos every Wednesday. As usual, all I've got left to say is thanks for listening, thanks for watching, thanks for your time, and keep safe guys. Cheers.